AZ 900 Episode 9. Hello, everyone. Welcome back to Azure Fundamentals course. In this episode, we'll be covering Azure Compute Services. Today's episode is the first one where we will learn about actual Azure services, and in agenda today we have virtual machines, virtual machine skill sets, container instances, Kubernetes service, app services, and functions. But all those services are part of so-called compute services. Compute services is a category of services in Azure allowing you to build and run cloud-based applications. So whenever this is a web application, web service, some scripting, desktop applications, compute services are here to help. Our first service on the list is virtual machine. But in order to talk about virtual machine, let's talk about virtualization in general. If you have a physical server, physical machine, what you will do first is install operating system, which will have some standard components like file systems, some services, some ports, and other configuration. If you'll want to run applications on this physical machine, you will simply install them on that operating system. But the problem with posting multiple applications on the same operating system is that they will share the same file system, same services, same ports, and other system configurations. And because there are no boundaries between those applications, at some point or another they will collide, and it doesn't matter whether they will use the same service or same ports. At some point they will collide, which is very bad. The thing that you can do to avoid that is to use virtualization where on the physical machine you install operating system. But additionally, you install virtualization software. Virtualization software will allow you to create virtual machines, so an emulation of a physical machine. That machine, since it's an emulated physical machine, will still have to get its own operating system. And on that operating system, you will be able to host your application. And this application now has its own sandbox. It doesn't matter what it will do on this operating system, it'll not impact any other application, cause other applications will be hosted on separate virtual machines with their own environments. This gives you a full separation and allows you to virtualize, emulate multiple physical machines using a single physical machine. So virtualization is simply set emulation of physical machines. It gives you ability to create different virtual hardware configuration per machine and per application. Additionally, you are able to install different operating system per machine per application to your application needs different systems. This is a way to go, and because those are totally separate machines, each application can freely use its own file system services ports, install any middleware, or apply any configuration it needs to run. And virtualization in the cloud is done through Azure Virtual Machine Service. The process is fairly simple. You either grab Microsoft prepared virtual machine images whenever there is two windows, or a closed machine. Microsoft already prepared virtual machine images for you in the marketplace that you can start from. Or if you want, you can configure your own system, install services, runtime applications, and ask your developers to prepare an image, a custom image for your own company, and put that image into some storage. An Azure Virtual Machine Service grabs those images and allows you to choose a custom or marketplace image to start creating new virtual machines and exposing them to your users. It doesn't matter which one you choose. In just a couple of minutes, a virtual machine will be provisioned and ready to use. Virtual machines are, of course, infrastructure as a service. That means you are responsible for managing both application platform and operating system configurations. Because of that, you have total control over the operating system and the software running on it. And as such, you have a support for marketplace, but also customer-provided images, so you can prepare your own images as a starting point for the virtual machines containing your organizational setup out of the box. With that said, this service is best suited for a custom software requiring custom system configuration or lift and shift scenarios. So moving your on-premise application to the cloud without a need to redesign. When it comes to supported scenarios, you can run pretty much any application, any scenario using virtual machines, whether this is a web application, web service, maybe a database, desktop application, or using this as a jambox to connect to a secure environment or just data gateways or many other scenarios that virtual machines can support. In Azure, you have multiple ways to create a virtual machine, either by navigating to the menu on the left-hand side, selecting Create a Resource, and finding virtual machines in the marketplace by going to the Compute section and selecting them from the top. Or you can go to left-hand side menu again and select Virtual Machines here, which will give you a list of virtual machines available in your subscription and allow you to hit Add button to create a new virtual machine. Virtual Machine CA has quite few configuration options but for today, we'll just go simple. We'll create a new resource group called AZ900VM. Select OK, provide a name. In this case, I will call mine AM Demo OVM. Next, we need to select the region, so where our Azure virtual machine will be hosted in which data center. Next, we need to choose the image, and this is the list of images prepared by Microsoft for us available directly from the marketplace. For now, I will choose Windows Server 2019. The next step is the most important choice when considering the cost of the virtual machine, which is the size. Size simply means how powerful is the hardware that we were virtualizing. In this case, I want B2 machine, which has 2 virtual cores, 8 GB of memory, and should cost me about $58 per month. If I'm happy with my selection, I simply hit Select. And as with any system, we need to provide a starting username and password for our administrative account. And I will select that I want to connect to this virtual machine later on through Remote Desktop Protocol. Everything else I can leave as default. Just for the demo purposes, let's head review and create to get our receipt about the virtual machine. This is the place where we can review all the details that we selected for the virtual machine. If you are happy with, we simply hit Create. And just wait a minute or two. Once the provisioning of the resource is done, you can select Go to the resource to navigate to the panel, which allows you to manage everything about your virtual machine, and it'll show you all the details about virtual machine general configuration. We can simply hit Now Connect. Select RDP for random mode desktop connectivity, which will download in file, allowing us to connect to this virtual machine. Simply open that file, select Connect. Select more choices and type in your account that we just created. And that's it. This is how simply you can create a virtual machine and log it to it in Azure by selecting an image size, pressing few buttons. And in just 2 minutes, you have a server virtualized in the cloud. So let's close that for now. And let's go back to presentation. Summarize virtual machines. They give you a lot of control over the system, but that also gives you additional maintenance. Therefore, I rate them quite high. When it comes to control and maintenance, they have no auto-scaling features, therefore you always work with one node, one virtual machine at a time. As such, the scalability of the solution is quite low because you cannot auto-scale. The only way of scaling is vertical scaling by adding faster CPUs or more memory, faster drives and things like that. Which brings me to the second point, virtual machine scale sets. And with this service, you pick an image whenever this is a custom image or a marketplace image. This image is automatically scaled across multiple virtual machines. Those virtual machines are hidden behind the load balancer, which redirects the traffic from your users or applications to one of those virtual machines. Within the scale set, the amount of virtual machines can be set statically by saying free 5, 10, or 100 or automatically with auto-scaling feature. So you can increase the amount of virtual machines in scale, set or decrease the amount based on your application demand. In that case, virtual machine scale sets are still infrastructure as a service because you're still managing the virtual machines. You need to still prepare images. They are a set of identical virtual machines created from the same image. As such, they have built-in auto-scaling features, allowing you to create and delete virtual machines based on demand, and they are designed for manual or AutoCAD workloads. So things like web services, batch processing, etc., etc. This is your way to scale out with virtual machines in the cloud. In this case, you still have quite a lot of maintenance, but high degree of control over the virtual machine scale sets. But in this case, you are getting auto-scaling features, so you can scale up to maximum of 1,000 nodes or 600 depending whenever this is custom or marketplace image. 4. Which makes scale sets one of the most scalable services in Azure. If you want to decrease the maintenance required, you can move away from virtual machines into containers. Containers are a little bit different than virtual machines. While there is still physical machine, there's still operating system underneath. But instead of installing virtualization software, we install container runtime. Within container runtime, you install containers. Container is a sandbox and environment for each application, and you can have multiple containers within a single runtime. The difference here The major difference here is that there's no operating system replicated across each container. As such, the footprint of the container is much smaller than the one of virtual machine. So what are the implications here? Containers don't have their own operating system. They actually use host operating system, but because application needs operating system to run, they emulate it. So while virtual machines emulate the hardware, containers emulate operating system to provide the sandbox environment for your applications. Because of that, they are more lightweight than virtual machines, therefore there's less development effort required for your team. There's less maintenance because you don't need to maintain the operating system patches, updates, and things like that. And because there's no operating system, there's less compute and storage requirements from those containers. As such, you can respond quicker to demand. So you can auto-scales faster than with virtual machines, but at the same time, they're pretty close to virtual machines. Therefore, they allow you to run pretty much any scenario in the cloud. That's why containers are so popular recently on the market. So our first service for containers is called Container Instances. And it comes to container instances. Instead of bundling entire system, you just grab the application, grab the configuration and other runtime middleware software that you need for this application to run. You ask your developers to bundle this application into a container image and host it into Container Repository. Container Repository is a simple storage service where you host your own images. Similarly to virtual machines, there are public marketplace and public repositories of other images for containers as well. You can then grab any of those images and push it to Container Instance, which will create a container group, a simple virtual machine underneath the scenes, and host your containers. Some containers might be exposed to users, some might not. It depends on what container really does. If it's web application, it'll be exposed to users. If it's a simple bot script, maybe it won't. And you can create more container groups and host more container depending on your needs. So let's summarize. Container Instances is your simplest and fastest way to run a container in Azure. And this is the first service that is categorized as a platform, as a service. And sometimes it's called serverless containers because you can actually abstract from the managing of the servers underneath completely. This service is designed for small and simple web applications, running background jobs, maybe some schedule scripts. Again, in Azure Portal, let's go to the marketplace and create container instance by selecting Create a Resource Typing Container. Finding Container Instances, Template, selecting Create, creating New Resource Group. I will call it AZ900ACI, giving the name of our container, which will be AMDEMO-ACI. Next, we need to select the region. I only choose West Europe. An image source, as I said, it's a marketplace. So I am choosing Quick Start Image, which is Microsoft-provided images, and a CI Hello World, which is a simple web application. Next, I am choosing the size of the container group, which is the host running my container, and simply hit Review and Create. Once this is done, I select Create and just wait for this to be provisioned. This service has been provisioned much faster than the virtual machine, under 20 seconds. Now we can go to the resource again, review all the details about the service, but for now we just want the public IP. I will copy this public IP into new browser window to open the web application that is currently hosted in my container. As you see, this is a very simple static HTML page, but this was containerized, and this is how simple you can create new containers and web applications once the image is ready. So let's go back to presentation. When comparing container instances to virtual machines and skill sets, you still maintain some degree of control because you are virtualizing operating system. So you can install extra runtime, extra software, but it's still much less than maintaining full-fledged operational system. In case of container instances, there's no auto-scaling. But the cool thing is that at minimum, you don't need to run any servers. So you can have 0 nodes running if you don't need any, but at maximum, you can have 20 container groups. Therefore, the scalability of the solution is not that great, but it's nothing bad. This service is simple for simple use cases. If you need scalability, there are other that deliver that. Services like Kubernetes Service. It's another service that allows you to work with containers using the same principle, either hosting your own containers within container repository or using marketplace public repositories. As such, Kubernetes Service can use those images to spread this across nodes. Of course, nodes underneath are VMs, but they're separated and abstracted from you. And Kubernetes is managing the deployment of containers across those nodes. As the deployment of containers is finished, Kubernetes exposes everything to users or applications through a load balancer, and it also gives you the same abilities like a scale set like static scaling or outscaling. So this system is an open-source container orchestration platform. It is actually available in pretty much any cloud. So it's not only Azure, but also AWS and Google Cloud. Additionally, this is one of the platform as a service offerings in Azure, and it's highly scalable and highly customizable. So while container instances were designed for a simple container deployments, Kubernetes Service is designed for high-scale and highly customizable deployments of containers in the cloud. And because containers are so similar to virtual machines, pretty much any scenario is supported. When comparing Kubernetes Service to other services, this is a very sophisticated platform offering, and because you are managing the containers and virtualizing operating system, the degree of control is pretty high, but it also requires quite a lot of skills from your team. Therefore, the maintenance is also high. And because it has auto-scaling feature and can scale up to 100 nodes at the time, because containers have smaller footprint than virtual machines, you can host more applications using 100 nodes than you can with virtual machines. But if we want to reduce the maintenance cost even further, we can move to app services. Main purpose of the service is building web applications. Whenever those are user-facing applications or web services, you ask developers to prepare a simple deployment package and send it to App Service. This App Service responsibility to deploy this package across multiple nodes and expose this to users. And it's really simple service. If you compare this diagram to our previous diagrams, you see there's much less work. There's no need to create any images and store them anywhere. You simply send your code to App Service and you're done. So App Service is Azure offering for hosting enterprise-grade web applications. And it is another platform as a service offering, and it supports multiple programming languages and also containers, which is pretty great because you can use any common language on the market that is used to develop web applications, and most likely App Service already supports that language. So if you have skills already available in your teams, you can quickly leverage App Service to host applications. Creation of web application using App Service is fairly simple. Just go back to the Azure portal, go to the left-hand side menu, select Create a Resource, and select a web app. When you select a web app, this will open a template for creating new app service. As always, select a resource group or create a new one. Mine will be called AZ900 App Service. Click OK and give your web application a name. Mine will be called a Demo App Service. This name is free. Publish. I will select Runtime Stock. As you see, there are quite many languages supported. For now, I will use TNet Core 3.1. I will choose Azure region for me. This will be a West Europe. And plan, which is the size of the virtual machine running underneath. So I can give it a name. And change the size. I will choose the free tier because this is just a demo. So hit Apply, Review, and Create. And if everything on the receipt looks as it should, and simply hit Create. As the resource has been provisioned, select Go to the resource to open the control pane for App Service. You can now use the URL to open your web application. By default, it'll be just empty template with empty static HTML page from Microsoft. If you want to deploy to this web application, it really doesn't take much effort. Your developers simply need to open a tool like Visuals Studio their code, type a simple command like tnet new MVC to create a new application template. Once the template is initialized, developers can use Visual Studio, do extension for Azure to open it, select their own subscription, select the app service that they want to deploy, right-click Select, Deploy to Web App, and just point to the location of their code. The extension will take care of everything else like packaging that code and sending this to App Service. And once the notification pops up, you can refresh the page to see TNet application deployed to Azure directly from developer machine in just a couple of seconds. So let's go back to presentation. When comparing up services to other services, you have less control over the hardware running underneath and over the platform itself, but you get a lot of cool stuff like auto-scaling feature, and you can scale up to 20 or 100 nodes depending on the pricing tier, which gives you pretty good scalability options for a simple web application service. It has a lot of enterprise-grade features, so the maintenance is also pretty low. And the last service on our list today is Azure Functions, also called Function Apps. This service is similar to App Service, but the difference is in App Services we were creating a full-fledged web services or web applications. But if we want to run a small pieces of code, let's say we have a function that adds to numbers A and B and returns a result, 9. If we want to run the small piece of code as a small web service, we again ask developers to prepare a small package and deploy this to Function App. Function App, similarly to App Service, will deploy this across multiple nodes and expose this as a web service. If you paid the attention, this might look to you very similar to how I presented App Services a moment ago. And this is true because Azure Functions are based on Azure App Service. So they have a lot of same features and a lot of new features that allow you to host your application pieces of code very effectively. So function apps are still platform as a service, although they are very often called serverless because they are completely abstracting the way that you manage servers underneath. So if there is no traffic, that means there are no servers and no charges with Azure Functions. You have two hosting, two pricing models, a consumption-based plan where you pay exactly for what you use, like 20 cents for 1 million executions, or you can have dedicated plan using App Services. So it's really up to you to choose what is best option for you. This service is really designed for building micro or nano services, state-led functions using a very small pieces of code. Therefore, they are very simple in nature. You should not be using Azure Functions to build fully fledged big services, although they can very nicely complement them if needed, because this service is serverless in nature. Therefore, it offers the lowest degree of control over the running infrastructure, but also requires the least maintenance from the development teams. And with its amazing auto-scaling features from 0 to 200 servers, it is one of the more scalable services in Azure. And with its amazing consumption-based pricing model, it is one of the core services for building very cheap and very scalable web applications. With that said, let's summarize, because this summary will help you to understand what do you need to take out from this episode. I know I deep dive into some services a bit more than required, but I have two purposes for creating this course. One is to prepare you for the exam and the certification, but second is to prepare you to work with Azure. Therefore, I don't mind deep diving into some specific topics if I feel it will help you with your work. So just remember that virtual machines infrastructure as a service are used to build solutions for custom software with custom requirements. Very specialized scenarios where you need high degree of control. And additionally, if you need auto-scaling features, then use scale sets. If you still want to run highly customizable environments, but you don't want to maintain so much, you can try containers. For a small and quick solutions using containers, try container instances. But if you need to scale out, you have outscaling scenarios, and you need high degree of control over the containers environment, you should go with Kubernetes Service. And if you want to host web applications in Azure, and you want to do it very fast, try App Services, an enterprise web hosting service in Azure that is very easy to start, very easy to work with, and supports a lot of programming languages. And lastly, if you have very, very small services, very small pieces of code that you want to run as web services, try Azure Functions. This so-called function as a service serverless. And it's designed to build nano services and has excellent consumption-based pricing. And it's again, very easy to start with because it supports the same programming languages as app services. This choice is always not so straightforward. For that reason, Microsoft prepared a compute decision flow that helps architects to decide which Azure Compute Services they should use for their application. Whether this is migration of existing application to the cloud or building something entirely new. And that's it when it comes to Azure Compute Services. If you like this episode, hit thumbs up, leave a comment, and subscribe to my channel to support my work. If you want to follow to the next episode, simply hit icon side or follow the playlist and see you in the next episode.